Ever feel like you're trying to have a conversation with a computer that just doesn't speak your language?
Like trying to explain a complex joke using only emojis.
Exactly. And that's where we get into the fascinating world of compilers and interpreters, the unsung heroes of coding.
They're the bridge between our human brains and the digital minds of computers.
So, ready to decode how it all works?
Absolutely. Let's dive in.
The thing is, computers think a bit differently than we do, right?
To put it mildly, they thrive on a language of ones and zeros, what we call binary code.
Binary code, right. Like the secret code computers use to communicate.
It's the fundamental language of computers. Every command, every piece of data, all boils down to those ones and zeros.
But we humans, we think in terms of words, images, emotions.
And that's the challenge. How do we translate our messy, creative thoughts into something a computer can actually understand?
And that's where compilers and interpreters step in.
Think of them as the ultimate translators, bridging the gap between human-readable code and the machine world.
So like when I write code in Python or Java, the computer doesn't actually get it right away.
Not in the way we understand it, no. Our code needs to be converted into those ones and zeros that binary language computers can process.
Okay, so compilers and interpreters are the key to making that happen.
Precisely. And just like there are different dialects and accents in human language, there are different approaches to this translation process.
So compilers, interpreters, these are the masterminds behind the scenes making sure our code actually runs.
Exactly. And each has its own strengths and quirks depending on the situation.
Okay, I'm intrigued. So let's break it down, starting with compilers. What are we talking about there?
Well, imagine a compiler as a master chef taking a whole recipe and turning it into a pre-made, ready-to-heat meal.
So instead of cooking every step, you've got the finished dish ready to go.
Precisely. And that's what a compiler does. It takes your entire chunk of code and translates it all at once into machine code.
Machine code, meaning that binary language computers understand.
Exactly. It's like taking that recipe and pre-cooking it so the computer can consume it directly.
That sounds pretty efficient. But what about those times when you want to adjust the recipe on the fly, like maybe swap out an ingredient or try a different spice?
That's where interpreters shine. Think of an interpreter as that skilled chef who prepares your meal step by step, reading the recipe as they go.
So they're more adaptable, more spontaneous.
You could say that. Interpreters translate and execute your code line by line, giving you more flexibility during runtime.
Okay, so we've got these two approaches, each with its own style. But before we get into the nitty-gritty of when you'd use one over the other, I think it's worth asking, why even go through all this trouble? Why not just teach computers to understand plain English?
The holy grail of computer science. While we're making amazing strides in areas like natural language processing, we're not quite there yet.
So for now, we still rely on these trusty translators, compilers, and interpreters.
They're essential. Think about it. Humans are great at abstract thinking, intuition, and creativity.
And computers.
Computers excel at precision, logic, and following explicit instructions. Our challenge, and the beauty of computer science, is figuring out how to bridge that gap.
So we've got our master chefs and our skilled line cooks, but how does this all play out in the real world of coding? Does choosing between a compiler and an interpreter really make that much of a difference?
Oh, absolutely. It's like choosing the right tool for the job. Each has its own strengths and weaknesses, and understanding those trade-offs can make you a much more effective programmer.
Okay, so let's break down those trade-offs, shall we? What are some of the key differences between using a compiler versus an interpreter?
Well, one of the biggest differences comes down to speed, how quickly your code actually runs.
Right, because who wants to wait around for their code to chug along?
Exactly. And when it comes to speed, compiled code generally has a significant advantage. Think of it this way. Remember our master chef who pre-prepares that entire meal.
Yeah, the one who's got everything portioned out and ready to heat.
Right. With compiled code, it's like that meal is already cooked and plated. The computer can just dig in and enjoy, no prep work required.
Whereas with an interpreter, it's more like cooking that meal in real time, right?
Precisely. Each line of code is translated and executed on the fly, which takes a bit more time.
Okay, so compiled code is like that super fast sports car. And interpreted code is more like a reliable, but maybe not as speedy commuter train.
A great analogy. Both will get you where you need to go, but one's definitely going to get you there faster.
Speed, got it. Now, what about errors? You know, those pesky little bugs that always seem to creep into our code. Is there a difference in how compilers and interpreters handle those?
Oh, absolutely. It's like the difference between proofreading an entire book versus editing a live performance.
Okay, I'm intrigued. Tell me more.
With a compiler, you get all of your errors up front during that initial compilation process. It can feel a bit overwhelming at first, like someone just handed you a manuscript covered in red ink.
Yeah, I can imagine. But at least you catch those mistakes early on, right?
Exactly. You can go back, fix those errors, and then compile your code again. With an interpreter, it's a bit more of a forgiving process.
More forgiving in what sense?
Well, you see, an interpreter translates and executes your code line by line, so you might not catch every error until that line is actually run.
Ah, so it's like you're rehearsing a play and you don't realize you flubbed a line until you're actually on stage?
Exactly. It can be a bit more chaotic, but it also allows for more flexibility and experimentation, especially for beginners.
Flexibility. That's an interesting point. So it sounds like interpreters might be a bit more beginner-friendly, even if they're not quite as fast as compilers.
That's a good way to put it. Now, another key difference to consider is memory usage. How much of your computer's memory your code takes up when it runs.
Because we all know that feeling of our computer slowing to a crawl when we've got too many programs open at once, right?
Exactly. And in terms of memory usage, compilers tend to be a bit more demanding up front.
Because they're translating that entire chunk of code all at once.
Exactly. It's like storing a whole library of books on your e-reader versus just downloading one book at a time.
So if you're working with a really complex program, memory usage is something to keep in mind when choosing between a compiler and interpreter.
Absolutely. Now, on the other hand, interpreters tend to be a bit more memory efficient.
Because they're only dealing with one line of code at a time.
Precisely. It's like reading a physical book. You only need to focus on the page you're on, not the entire book at once.
Okay, this is all incredibly helpful. So we've got speed, error handling, memory usage. Are there any other major differences that we should be aware of when choosing between a compiler and an interpreter? So we've talked about compilers being like meticulously planned novels, right? And interpreters, they're more like that dynamic improv show adapting on the fly. But is there ever a middle ground? Like, can you combine those approaches?
You're thinking like a true innovator, and the answer is absolutely. There are hybrid approaches out there, and Java is a prime example of how it can be done really effectively.
Okay, hybrid approach is Java. I'm listening.
So imagine a well-run restaurant kitchen. You've got this intricate dance of efficiency and flexibility happening all at once.
I'm picturing a team of expert chefs working in perfect sync. What's the Java connection?
Think of it this way. You have your head chef representing the compiler. They take the original recipe, which is your Java code, and they translate it into a simplified format, something that's easier for the line cooks to follow.
Okay, so it's not the final dish yet, but it's prepped and ready for the next day.
Exactly. We call this streamlined format bytecode. Now, the line cooks, those culinary masters, they represent something called the Java Virtual Machine, or JVM for short.
JVM, got it. And they're the ones who take that bytecode and actually execute it.
Precisely. But here's where it gets really interesting. The JVM, it has this secret weapon called just-in-time compilation, or JIT for short.
JIT compilation. Sounds like those line cooks are about to get a serious speed boost.
You could say that. Imagine this. The JVM is really observant. It starts to notice that certain parts of the recipe are being used over and over again. And to speed things up, it starts preparing those elements in advance.
Ah, so it's like having a sous chef who anticipates every next move, making sure everything flows smoothly and efficiently.
Precisely. JIT compilation takes those frequently used bits of bytecode and compiles them into that super fast machine code on the fly.
So Java gets the best of both worlds. The flexibility of an interpreter with the speed advantages of a compiler.
You got it. It's a really elegant solution that combines the strengths of both approaches.
That's amazing. But I have to ask, why does all of this matter to someone who's just starting to learn about coding?
That's a great question. Understanding the tools of your trade is essential in any profession. And coding is no different.
So knowing the difference between a compiler and an interpreter and how they work can actually make you a better programmer.
Absolutely. It helps you write more efficient code, make smarter decisions about which language to use for a particular project. It's all about having that deeper understanding of how things work under the hood.
And that knowledge is especially important in fields like AI, right? Where speed and efficiency are everything.
You hit the nail on the head. Frameworks like TensorFlow, they're used extensively in AI, and they rely on these super fast compiled languages for their core operations. But here's the interesting part. Even though the engine under the hood is built for speed, A lot of AI tools provide interfaces in languages like Python, which is interpreted. It's all about layers of abstraction, making it easier for developers to focus on building those intelligent algorithms.
This has been an incredible deep dive. We've gone from the basic building blocks of how computers think all the way to the cutting edge of AI. And at the heart of it all are these unsung heroes, compilers and interpreters, silently working behind the scenes to make our digital world possible.
And who knows what the future holds? Maybe one day we'll be having this same conversation with an AI, marveling at how far we've come in bridging the gap between human ingenuity and computational power.
That's a deep dive for another day. To all our listeners out there, keep exploring, keep questioning, and keep coding. The digital world is constantly evolving, and who knows, maybe you'll be the one to write the next chapter in this incredible story.